Alrighty. So for the Chapter 9 practice test, yeah, there's lots of stuff on that pink copy you have that we took off. Anything with recursive is basically gone. We're not testing you on recursive. So that's why I have X's in these recursive spots right here. And then you're going to notice that anything that I have circled in red is something we're going to cover today, whereas the other ones we'll just kind of skip through because I want to focus on what you're going to see on the test tomorrow, and then hopefully give you a little time to work on the review as well. Now, before everybody came in here, I wrote the 5 formulas that will be given to you tomorrow. There'll be like a pink sheet that has all the formulas on it right here. So before we get started, one of the things students do, which is a good idea, is when they get their formula sheet, they go through and they at least label arithmetic, arithmetic, geometric, 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 you know, those types of things, so that they know which ones they're supposed to be looking for. So take a look at this one in the top left corner here. Arithmetic or geometric? This one's geometric. This is for finite geometric. Notice there's no pluses in it, right? Okay. How about this one? What's this for? That's arithmetic rule right there because it has the plus in it. What's this one? Geometric rule. Arithmetic. This is Gauss's. Remember the arithmetic for sums. That's what the big S is for. How about this one? Yesterday's nice and easy infinite geometric formula. So if you do that, as soon as you get your formula sheet, you just kind of label them off. That will relieve some tension, you know, as you're taking the test, because you're like, oh, these are the formulas. I just had to know which formulas work for what. So determine whether each sequence is arithmetic, geometric, or neither, and like I said, avoiding the recursive stuff. So write a recursive and an explicit formula. No, we're just going to do explicit. So take a look at number 1. 23, 29, 35, 41. Benny already had that one. What is that one? It is arithmetic. So then you'll go to your formula sheet and you'll go, oh, it's the one with the plus in it. A sub n equals a sub 1. I'm going to write it down here. Plus the quantity n minus 1 times d. And then you just have to remember which two numbers we had to find so we could write that formula. Which two? Good. A sub 1 and d. And a sub 1 is pointing right at us there. It's 23. So a sub n equals 23 plus n minus 1. What was d? Yep, they're adding 6 every time. And then distribute, simplify, make it look really nice. So in the end, I'm going to run out of space here. Let me try and squish a little so I'm not skipping steps. Is that what you got while I was trying to rewrite that and everything? All right, so that goes in the explicit slot. And we have one more slot we have to fill. How do we do this? Yeah, that nice little formula we just had, just put a 10 in there. And I don't know that a lot of people are even going to show work for that. I don't know that I would. You know, I'd go up here and put a 10 in and say, oh, that's 60 plus 17. That's 77, you know. So you just get those formulas down and things should roll along pretty good for the first few anyway. Alrighty, let's take a look at number 2. It is geometric. So then you go for the rule that doesn't have a plus in it. Remember, these are the two that are the rules, and this is the one without the plus. So a sub n equals a sub 1 times r to the n minus 1. And what do we have to put into that formula? A sub 1 and r. Good. And you kind of already found r when you were trying to figure out if it was arithmetic and geometric, right? What did they multiply by? Yeah. So there's our explicit rule. What do we do about that 10? A sub 10. Yeah, again, plug it in. And this one, yeah, you'd probably want a calculator unless you have 3 to the 9th memorized in your head. Because we're going to put the 10 in here. 10 minus 1 is 9, so 5 times 3 to the 9th. Oops, got to put this down. 98,415. Oh, there's that blue again. Just when I think it's going to work and everything is fixed, then I have to pause. 98,415. All right, so definitely should expect some problems like that to begin this test. And then, like I told you, we're skipping recursive. So we're going to go to numbers 4 and 5. Well, these are kind of silly. Why don't you go ahead and do 4 and 5 while I fix attendance here? Because I'm certain you know how to do those. Some of you maybe didn't have a calculator available for finishing up number 5 there, but I'm sure you got the first 3 there. Anybody need to ask how to do those? I shouldn't have said I'm sure everybody can do these, but I remember when we did it in class, you were like, boom, we got this, and just rolling right in front of me, so. We put a 1 in, get the first term, then a 2, then a 3, then a 4, and a 5. Same thing for number 5, but probably with a calculator handy, you know. Or you realize, well, if the first term is a 3 and r is 4, I just need to keep multiplying by 4. You know, and that's how I get the next terms. Anybody need more time for 4 and 5? Alrighty, 6 and 7. Hey, no fair. Those formulas aren't up there for these. They're not. But I think we can do this. Find the missing term of each sequence. The middle one is missing, and it's arithmetic. Anybody remember how we find it? Exactly. Add them together and divide by 2. What you got? 25. But I don't think that's how we do number 7. You remember? Oh, so we have some people that are remembering the formula. Here's the other way. Remember, you put the G's in the 2 means spots, and then you put the 45 and the 5 in the other 2. So, let's see if this works out nice. 225, that seems like a number we've heard of as a perfect square before. Now, the plus or minus is kind of a big deal, right? Because we're taking the square root there, so plus or minus 15. So either way, you either memorize the little formula, geometric mean equals plus or minus the square root of xy, where these two numbers are x and y, or you put it in those means positions here, and you'll get it. You don't get that formula. Those you have to know. You gonna be okay with that? Determine if it is arithmetic, geometric, or neither. If it's arithmetic, give the common difference, d. And if it's geometric, give the common ratio, r. So take a look at number 8. Think about it for a little bit. What is it? It is geometric. So that means it has an r. Do you remember how we found r yesterday? Yes. There it is. 1/4. Take a look at number 9. Arithmetic. So it's got a D, a common difference. What is it? Good, -3, because remember it has to be what we add to each term. How about 10? Take a peek. Yeah, doesn't fit. I mean, they're not obviously not adding the same amount every time. And if we take 13 and divide it by 9, that's not the same thing as 21 over 13. Remember, it has to be consistent the whole time. You're taking the test and you're like, oh, I can't remember which one gets a D and which one gets an R. Silly test taker. Look up at your formulas. The ones with the pluses have the D's in them. So there it is. It's a common difference. Ooh, this looks like a fun one. Use the given information to write an explicit arithmetic rule and then find the 10th term. Well, first thing I do, write the rule down. And think back to what we said earlier, which is we need the first term and we need D. Oh, they gave us the first term. That's a 2. Unfortunately, they did not give us D. So that means D is going to have to stay put. And I have to figure out a number I could put in for N and something I could plug in for A sub N. Ideas. This is an N right here, A sub 6, A sub N. And that, if we put it in, is supposed to give us an answer of 32. Hey, now we can find D, no sweat. So, order of operations, 6 minus 1 is 5. Subtract your 2 from both sides. And divide by 5. And here's where we're going to resist the urge to say, we're done, because we're not. You know, we did the hard part. The hard part was figuring out what the A sub 1 and D are. So now we can go back and plug them in. Distribute, simplify. And no, I'm not talking through those steps with you anymore because we're at the end of Algebra 2. We're not at the beginning. At the beginning, I would have talked through every little piece of that with you. Almost done. What's left? Exactly, and thank goodness for that little slot over there so we don't forget, right? So 60 minus 4 is? And we have it. Some students would say that is probably one of the hardest problems on the test. I mean, you have to show the most work, you have to do the most work to find things that are missing, but you have the formulas. They're going to be given to you, so if you know which one to use for what, it's not going to be a problem. Alrighty, we're skipping those 2, those 3, all the way down to 15. Sorry? Oh, yeah, you were helping your girlfriend, so you weren't here earlier. We're only going to focus today on the ones that you will absolutely see on the test tomorrow. So, taking everything else off. No distractions. Alrighty, looking at 15. I see sigma. That means sum. SSS. Got to be one of those. I wonder if that's arithmetic or geometric. Which is it? It is. Good. Arithmetic has an n to the first. Right there. That's arithmetic. So then I look over here. Which one of these was the arithmetic formula for sums? Which one has the plus in it? Right there. Now we're going to let the formula drive us. Figure out what we have to have. Ooh, I need to know n right away. Sum of how many? Good, 22. Upper limit minus lower limit plus 1. Now, they didn't give me the first term, but I think we could find it, couldn't we? What is it? It is 3. Put a 1 in here. Negative 2 times 1 is negative 2, and negative 2 plus 5 is 3. The last one. How do we get the last one? Exactly. Take the upper limit and plug it in. Negative 44 plus 5 is? Do a little bit of math in your noggin, or not. We talked about this when we went through this section. You could use parentheses all over the place and just punch this in if you want to, but usually people have much more success if they do a little bit of math themselves. And what does that come out to in 15? Somebody punch it in yet? Thank you. Again, formulas, get the formulas, you're good to go. Need more time? I see people still scrambling to write like crazy. Let me hold on. Anybody still need more time? All right. 17, 18, 19, 20, and 21. Oh, we're hitting this whole page here. Well, except for 16. Alrighty, number 17. Evaluate each infinite geometric series if possible. Does it converge? Does it diverge? And then find the sum if you can. Get my glasses on here. 17. How do you know? It is getting smaller. R, yes. So 15 divided by 30, 7.5 divided by 15, 1/2. So it converges. Remember, C's for a grade are better than D's. Converges are what we want to see because then we can actually find it. But I think I need a special formula for that. Which one? The little baby one that we just did yesterday. S equals a sub 1 over 1 minus r. First term is right there. They gave it to us. If you wanted to, use parentheses on the bottom, punch it right in. Or you could say, I know 1 minus 1/2 is 1/2. Multiply by the reciprocal. If you want to do it by hand. 18. All of them reduced to negative 1/3. So we can do that one. Converges. Same formula? Yep. Extra negative to keep track of, though. So minus a negative is going to make that a plus. That's going to be 4/3. Again, you can do that on your calculator if you want to. You could do that on your calculator too. 670 divided by 4/3. Anybody do it yet? Get something punched in. No, I got something smaller. 506.25. That's what I got. Anybody else punch it in? 506.25. Oh, you left it as a fraction? Okay. Yeah, I would guess, since most of these are fill in the blank and multiple choice, I think there's 4 of them that aren't. probably safe with the decimals on these, even though, like we said during class, if they don't come in decimals, you're really not supposed to give the answer in decimals, but we're trying to make it easier on Schoology. Alrighty, take a look at 19. Getting bigger and bigger and bigger, isn't it? We can't do that one. C's are better than D's. D is the bad one. So, no sum. No sum. We can do the one. Converges. C's are good. Oh, I'm sorry. Did I move that too fast? Doggone it. Is everybody done with that? I forgot to ask. All right. Number 20. Determine arithmetic or geometric, then evaluate the finite. Ooh, that's a big hint. Finite series for the specified number of terms. So right away I start thinking, finites. Can't use this one anymore. Remember, this doesn't have a little n here. That means this is for all of them forever. That's the infinity one. This or this? I don't know yet. Figure out if it's arithmetic or geometric to do that. So look at number 20. Arithmetic, what are they doing? Ooh. Uh-oh. Put the eraser back in the wrong slot. What formula should we use? Gauss's. S sub n equals n over 2 times a sub 1 plus a sub n. Well, let's get to work and see if we have all the stuff we need. Do we know how many? They said 10. They told us that. Do we know the first one? It's right there. It's a 2. Do we know the 10th one? No. Now, when we don't know something, when something is missing with arithmetic, what do? Some of you right now are like, well, I know the difference is 6, so I'm just going to keep adding 6 until I get to the 10th one. No! Remember, this is about formulas. Yes, this little bugger right here, the rule. So this would probably be one of those that's not a fill in the blank and not multiple choice, and I'll be grading your work and looking at all the steps. We do know what the first term and D are, though. I mean, that was one of the first things we did, was figured out they're adding 6 every time. So we'll pretty that up. Deja vu. Didn't we have that exact same formula earlier on the test? How do I use that to find what I need? Exactly. Plug in a 10. 60 minus 4 is, yeah. Do a little math by hand. Again, you don't have to, but it sure does make the punching in go a little easier. Somebody punch in already? 290. Again, probably one of the tougher problems, students would say, and not necessarily tough. It's just making sure that you find everything that needs to go in the formula. Well, if that one's arithmetic, I highly doubt that the next one's going to be arithmetic, right? Okay, so take a look at number 21. What do we got? It is geometric, multiplying by -4. I want a formula to guide me. Which one? Exactly, the one with the N. N means it stops. Let's let it guide us. Do we know how many? They said 8. Do we know the first one? It's right there. Didn't you just tell me what r was just a minute ago? Yeah, it's -4. But make sure you put that in parentheses or you're going to have problems. And then on the bottom, same thing. If you're just going to use a calculator on this, make sure you're putting parentheses around those negatives. So let's just say I decided I don't want to do any math in my noggin. I'm going to have to start here because the order of operations says I have to do powers first. So I'd have to do my parentheses, -4, parentheses to the 8th. Boom. Then I need 1 minus that. So 1 minus second. Where's little answer? There it is with the negative. Uh-oh. Thought I had it in there right. Let's try again. Huh. I don't know what I punched it. Oh, I hit the negative instead of the minus. That's why it was mad at me. Then I have to take that times 3. And then, like I said, if you don't want to figure out that 1 minus a -4 is 5, you wouldn't have to do that, but you're going to have a lot of parentheses. There's the answer. -39,321. Now, myself, I would have gone ahead and figured out that that was 5. You know, at least to make that a little bit easier to punch in as you go through it, but you don't have to. If you're very careful with your parentheses, you can just turn it over to the calculator at that point. We're not going to put a wordy problem on there. So, I certainly could make up some others. If you want to go take a quick peek back at what we did today and see if there's any like, hey, could you make one just like that? So we're going to be good to go tomorrow? Okay, again, this is half the battle. If you know the formulas, you know which one is for what, just let them guide you as you go through it. And I also shortened up the review for you. And we have quite a bit of time. So you might be able to almost finish this one. Again, I went through the review and I said, well, we're not doing recursive, so I took those out and went through and took the things out that we did not cover on that practice test today. That way you can just focus your energy on just the problems we did. What were there, like 17? I think the test is 14 problems long. So there you go.